Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects also along with the Engineering Drawing. Do subscribe the channel and get alerts. Now, let's see some special problems in the projections of plane surfaces here. Here, basically, all these problems are given a different shape, and its shape is changing to some regular shape, and we have to find the angles also. The angles are not directly given, and we'll see how to draw them. A rectangle is given. It is appearing like a square, okay, in the top view, and is resting on one of its edges in HP. So a rectangle appears like a square here like this. That means the angle is not given and we need to find out. Okay, next. The edge on which it rests on HP makes an angle 45 degrees with VP. This edge is also making an angle 45 degrees with the vertical plane. And finally, the plane appears like this. Let us see how to draw it. Now, let's take the reference line and draw the rectangle here such that the longer edge is parallel to the VP. Okay. And why we have taken this in the VP is we have to show this as a rectangle and this rectangle as a square. So this rectangle appears like a square only when these longer edges, say which is 80 mm, appears to be of only 50 mm, shorter. That happens only when it's these lines are making angle with HP. So these lines are making angle with the horizontal planes. That is possible only when this surface is making angle with the horizontal plane. So let's take the horizontal plane. In the horizontal plane, the rectangle first. Next, let's draw its projections. So the initial position is over. Now, actually, earlier we used it to show the surface inclination in the front view, and then from that we use it to draw the top view. But here we don't know when, at which angle this rectangle appears like a square. So we do it indirectly. We draw the square here such that all the edges, even though this is 80 mm, all these four edges appear like 50 mm only. Then only you will get the square. So from this top view itself, let's draw the top view here like this. We draw the square here. The square is drawn first. Okay. Now from this, let's take the front view. How? Take the AD edges in the horizontal plane. So I'm assuming that this plane is lifted like this in this direction. That means AD edge will be in the horizontal plane like this, AD. And BC edge is lifted up, is on the above. At where the length of the front view won't change, but it is at an angle. At which angle? At a particular angle, we are able to see this as a square. That's why in the front view, the front view, of course, BC will be lying only on these projectors, right? It can't be away from it. So we have drawn the projector from BC. And now let's draw this front view by taking this length 80 mm as radius and this A dash or D dash as the center. We draw an arc here where how much? 80 mm angle. This length is 80 mm. From this, we get the inclination of the surface. We can measure that. Okay. Now, we are able to find the angle at which this rectangle appears like a square. Now, the edge on which it rests on HP, this AD edge is resting on the horizontal plane. So AD edge is perpendicular to VP or parallel to HP. It is making an angle 45 degrees with VP. So let's take a line here at 45 degrees angle. On this, we take the AD edge. The AD edge is marked here, and with these 2 points as reference points, We mark the other 2 points BC. Now, join all the points by straight lines. We have just reproduced the same top view here in a different position, such that this AD edge is making the required angle. So the top view is redrawn. Okay, just we have rotated the plane surface clockwise like this. When you rotate the plane surface clockwise, you get the top view. Now, from this, let's draw the front view. Draw projectors from all the points and draw horizontal lines from these points and mark the intersection points here, A, B, C, D. Join them by straight lines. We get the front view. So this rectangle appears like this in the front view and appears like a square in the top view, having one of its edges. Of course, this edge is true inclination only because AD edge is in the horizontal plane. That's why this angle, whatever you see in the top view, is true inclination. So these are the projections of the rectangle appearing like a square. Now, let's take another example. An isosceles triangle is taken here, and this isosceles triangle dimensions are given 50 mm base and 80 mm altitude, but it is appearing like an equilateral triangle, means all the edges are 50 mm. Okay, now let's see how to draw this. So here this is isosceles triangle appearing like an equilateral triangle here and having one of its base, the base AC is in HP and at a 60 degrees angle to VP. So this edge is at 60 degrees angle to VP. In that position, this triangle appears like this in the front view and in the top view. Let us draw its projections. So first of all, you have to take the plane where, in which position actually. We have to first of all think of the initial position, how to take the first position, an isosceles triangle. Okay, the base edge. We want the base edge in the horizontal plane. Okay, and at some angle, 60 degrees angle to VP. That is one indication that we have to take that AC or the base perpendicular to the reference line. That is one thing. Second, its surface must be making angle with the HP. Then only we'll be able to see this isosceles triangle as an equilateral triangle. So we take the isosceles triangle like this. AC is taken perpendicular to the reference line, that is VP, and the isosceles triangle is constructed having the base 50, altitude 80, this perpendicular distance, perpendicular to the AC. Okay, this is altitude. Altitude is 80 mm. Now let's draw its front view. Mark the front view here, and as we have seen earlier, we used to show the surface angle here, but we don't know at which angle it appears like an equilateral triangle. So let's go it in the indirect way. Let's take the same top view here and let's draw the isosceles triangle, an equilateral triangle. Let's draw an equilateral triangle first, having all the sides 50 mm. This is the 50, 50, 50. All the sides are 50 mm. And let's draw the top view. An equilateral triangle is drawn. Next, from this, we draw the front view. How? The AC edge is taken here. And coming to the front view, absolutely there is no change. It appears like a straight line only in the front view, but at some angle to the horizontal plane or reference line. So the same length, 80 mm, this is 80. The same 80 mm length is appearing in the front view, is seen in the front view at some angle. But where? We have drawn the AC on the horizontal plane and assuming that the point B is moved upwards. And even when it is moved upwards, its front view and top view must lie on the same projector. So from B dash, we draw a projector here. On this projector, from this point here, A dash, C dash, we draw an arc here with 80 mm radius. And this point is marked as B. So this is the front view. Now you can measure this angle, the angle of surface inclination with the HP, at which this isosceles triangle is appearing like an equilateral triangle. Now, we want this AC at 60 degrees angle to VP. It is resting on HP. Okay. Let's take a line here at 60 degrees angle, and AC is marked on this. AC is marked on this, and with these 2 points as reference, B is also marked. Join all the points by straight lines, and just the same top view is reproduced here. We have just rotated the point B like this, anti-clockwise direction, and we have reproduced the same top view. Now let's draw the front view. Draw projectors from all the points. Draw horizontal lines from these points. Mark the intersection points, corresponding intersection points. So from A here, A dash, you get A dash, the front view. So like this, A dash, B dash, C dash, join them by straight lines, we get the final front view. So this isosceles triangle appears like this in the front view, and like an equilateral triangle, but having one of its edge at 60 degrees angle to the VP in the top view. So this is the one typical problem in the projections of plane surfaces. Let's see another typical problem. An ellipse of major axis and minor axis are given. It is appearing like a circle in the top view. When it happens, its major axis must be making an angle with the HP. So then only it's possible. So this is the ellipse here. This ellipse appearing like a square, a circle. It is ellipse having major axis and minor axis appearing like a square here when its surface makes an angle with the HP. And we need to find out. This angle is not given, we'll find out. And also its minor axis is at 45 degrees angle with VP. Its minor axis is making, this is the minor axis, isn't it? So this minor axis. This minor axis is at 45 degrees angle to the vertical plane. So in this position, we have drawn the front view. So the plane, the elliptical plane surface appears like this in the front view and in the top view. Now, let's draw its projections. Let's take the ellipse having major axis parallel to the horizontal plane or reference line. Major axis here, minor axis perpendicular to the reference line, because when you tilt the surface, right, when you, the front view, in the front view, it appears like this. Let us see. So first show the dimensions, major axis and minor axis. And let's take the points here on the surface, A, B, C, D, E, like this, number of points. All the points are marked. And let's draw the front view here by drawing the projectors and the front view here. All these points are marked as A dash, B dash, like this in the front view. Now, when this surface, right, this is a 75 mm long line. This 75 mm long line, that is major axis, should become 50 mm only. That is, it has to be a length of a diameter of the circle, which is equal to 50. Why 50? Because this is the minor axis is 50. So major also is coming up, becoming 50 mm. That's why it appears like a circle. So this is making an angle, surface angle with the HP. So to get it, we draw the top view first, such that we draw the circle, right? We draw the circle first, and from this, indirectly, we get the surface angle, right? So we draw this front view or top view first. In the front view, point A is marked, and from E dash, you draw a projector. In the front view, the same length appears here also when it's a surface making angle with HP, but at some angle. So take this same length, 75 mm long line, and from A dash, draw an arc with the 75 mm radius. You get a E dash here. Now join it by a straight line. That is the front view. So the same front view is redrawn in a different position. That's all. Now, we are able to draw the first and second positions. Now, the third position, that is, its minor axis means here, for this, if you see this circle, all are same. All appears to be same with this either AE or GC, all appears to be same. But when you see this ellipse, this GC is the minor axis and AE is the major axis. So we are talking about minor axis. That means GC. So this GC, how is this GC? GC is a point in the front view. That means it is perpendicular to VP or parallel to HV. Now, that means this line, GC length, we are able to see the true length. So the true length is visible and true inclination also visible for GC. So this GC line is at 45 degrees angle to VP. Draw a line here at 45 degrees angle. Okay. All the projectors are drawn and marked the front view. Now, 45 degrees line is drawn. On this line, we take this GC points, G and C points here. GC are taken here. And with these 2 points as reference, let's mark the other points. Find the other points with the distances here from this. So after getting these points, join all of them by a smooth freehand curve like this. So the circle here is reproduced here in a different position, such that this GC edge, which is perpendicular here to the reference line, is taken at 45 degrees. Now, let's draw its front view. Draw projectors from all the points. Draw horizontal lines from these points and mark the intersection points here. Join all these points by a smooth freehand curve. We get the final front view. So this is the front view and top view, the final projections of the elliptical lamina. Okay. So these are the various typical problems which you come across in the projections of plane surfaces. Hope you enjoyed the topic very well and understood it very well. If you like it, hit the like button and like, share and subscribe. Thank you.